Alright, here we go. This is the video lesson for solving equations and inequalities with variables on both sides. So, I'm going to first start out by giving you three pretty simple rules to follow when you're doing equations that look like this. The first rule being that you need to first simplify each side of the equation individually. If you're looking at the two equations up here on my on the screen, example 1, example 2, again, if you would simply draw a line down the center, there we go, breaking up sides of your equations, you'll understand what I mean. Simplify each side of the equation first. So if you look at example 1, this left side, you ask yourself, is there anything that can be done with 4x plus 12? You should be saying no, because 4x plus 12, they are not like terms, so you can't combine terms or anything. Same thing on this side for example 1. There is nothing to be done over here because 2x plus 20, these are not like terms, so there's nothing that can happen on the right side of this first equation either. So for step 1 on example 1, nothing you're going to do there. However, in example 2, you'll see that if you look at the left side of the equation here, there is something that can be done over here to simplify it, and that would be to distribute your 5. Same way with the right side of this equation, the first thing that you can do to simplify here is to distribute your 2. So that's what I mean when I say simplify each side of the equation first. First decide whether there's something that can be done to each side before we start moving things back and forth across the equal sign. So we'll come back to those examples in a minute. Let's finish up the rest of our rules. The second rule being, after you've simplified each side of the equation, the second rule is get the variables on the same side so that they can be combined. Again, if the variables are on opposite sides, you can't combine them, but once you've moved the variables so that they're all on the same side, you can combine your variables because they'll be like terms or combined like terms. And then the third rule here is solve the multiple step equation, because once you've combined your variables so that you only have one variable, all you're left with is a multiple step equation, which we learned in the last lesson, solving multiple step equations. We learned how to do that. So once you've done the first two steps, you just have a multiple step equation that needs to be solved. So here we go. Let's look at example 1. We've already determined that step 1 is done because there is nothing that can be simplified individually on each side. So we move right on to step 2, which is get the variables together. So here is a 2x and here is a 4x. They are on opposite sides of the equation, and I want to put them on the same side. Well, in order to do that, I need to undo what that variable is doing on its side, on its individual side. So, for instance, this is a positive 4x. If I wanted to turn that into a 0, I could subtract 4x on both sides. That would be fine. I'm not going to do that, however, because by subtracting 4x, I would end up with a negative x, or a negative value on the right hand side over here. And I don't like negatives, I like positives. So instead, I'm going to subtract 2x. And again, I'm going to do this to both sides of the equation. And the reason being that 2x minus 2x right here becomes a 0, so you can just cross that out, and you're left with just 20 over here. And what that did is that moved that 2x over to the other side. Now, as you move it to the other side, it becomes a negative 2x, but you're again just combining like terms. Here I have 4x minus 2x, which gives me 2x, and I still have the plus 12 that was originally there. So like I said, that is taking care of step 2, which is getting the variables on the same side so they can be combined. I did that, they're combined, and now I just have a simple two-step equation. We've already learned how to solve a two-step or a multiple step equation, so we are going to subtract 12 on both sides, giving me 2x equals, what is that, 8, and last step would be to divide by 2, x equals 4. So that is how example number 1 is done. Now in example number 2, as I mentioned earlier, there is some things that we can do individually on each side. So the first thing we're going to do is on the left and the right side, we're going to distribute. So on the left side I distribute the 5, I get 5x plus 10. On the right side I'm going to get 6 minus 2x. Now I can look again and say, is there anything that I can do over here on the left side? Well, no, because 5x plus 10 are not like terms, so I can't combine those. And same thing on the right hand side, 6 and negative 2x, those are not like terms, so I cannot combine those. So there is no other individual work to do on the right side or the left side separately. So now I need to, step 2, move my variables to the same side. Again, in this case, I could either subtract 5x on both sides, because positive 5x and negative 5x would cancel, but I don't want to do that because that again will give me negative x's over here, and I don't like negative x's, I like positive variables. So instead of subtracting 5x, I'm going to add 2x to both sides. Again, negative 2x plus 2x cancels out or becomes 0, leaving me with just 6 on the right side. On the left side I have 5x plus 2x, which is 7x. My plus 10 just drops down. And again, I have a simple two-step equation, which we learned to solve in the last section. Solving this two-step equation, I would subtract 10 on both sides. 7x equals negative 4. Then I would divide both sides by 7, giving me x equals negative 4/7. Okay, here we have our last 3 examples. Again, a lot of the same stuff. We're going to look at example 3. I'm going to look at the two sides individually. I'm going to say, okay, there's nothing I can do over here on the left side, because 3/8 minus 1/4 x, they are not like terms. Same on the right. 1/2 x minus 3/4 are not like terms, so I cannot do anything there. So now I want to get my variables together. Again, I'm going to look at this and I'm going to say, I am going to add 1/4 x this time to both sides. Again, so that I will have positive x's. Over here on the left side, a negative 1/4 and a positive 1/4 becomes 0, leaving me with just 3/8 on the left side, equals. Now on the right side I have 1/2 x plus 1/4 x. Make sure you remember how you do your fractions. 1/2 x I'm going to think of as 2/4 plus 1/4 gives me 3/4 x. And then I have the minus 3/4 that drops down. Now I again have a two-step equation, or a multi-step equation, where I'm trying to solve for this x. I'm going to first add 3/4 to both sides, and once again we have fraction work to do here. On the right hand side, the negative 3/4 positive 3/4 cancel, that's fine. On the left side I have 3/8 plus 3/4, so I'm going to think of that as 3/8 plus 6/8, so I have 9/8. I'm going to go ahead and leave that as an improper fraction because I have 9/8 equals 3/4 x, and I know to solve for x now I need to multiply by the reciprocal. The reciprocal of 3/4 is 4/3, so I'm going to multiply both sides by 4/3. On the right hand side, the 4's and the 3's cancel, leaving me with just x. And in this case, x is going to equal, on the right hand side, 3 and 9 reduced to 1 and 3, 4 and 8 reduced to 1 and 2. So I'm left with 3/2. So x equals 3/2. Obviously, you could change 3/2 into a mixed number, 1 and 1/2. Either one would be fine. Either answer. Obviously, you don't need both. I would just leave the mixed number. Alright, moving on, example 4. Again, looking at my two sides. On the left side, looks like I have some work to do before I start combining like terms. So I'm going to distribute my 3, giving me 3a plus 3 minus 5 equals 3a minus 2. Now, again, I've done that because that was the left side. It had some work that could be done before getting your variables together. Now, I'm going to again look at my left side here because there's a lot going on here, and I'm going to say, wait, there's something else I can do over here because positive 3 and minus 5 are like terms. I'm going to go ahead and combine those two like terms and now say that the left side is 3a minus 2 equals 3a minus 2. So positive 3 and negative 5 makes negative 2. I just simply did combining like terms. Alright, so now I have 3a minus 2 equals 3a minus 2. I want to get my variables together, so I'm going to subtract 3a on both sides so that on the left side positive 3a and negative 3a cancel, they make 0. But wait, on the right side positive 3 and negative 3a also make 0. Well, don't stop, keep writing. What do you have left? Negative 2 equals negative 2. Now, here's a special rule for everybody. Sorry about that. If the variables cancel completely out on both sides and you're left with something that looks like this, meaning there are no variables left in the problem, you are either going to have a true statement or a false statement. In this case, we have a true statement. Negative 2 does equal negative 2, obviously. You could have something that maybe said negative 2 equals 8, which obviously is a false statement. All right? Your two answers depend on whether you have a true statement or a false statement. In the problem we have done, we have a true statement, which means our answer is all real numbers. So that is the answer to example number 4, all real numbers. Now, all that means is that you can take any number and plug it back into this equation. If you say 5, plug 5 into the equation, you're going to get a true statement. Plug in negative 2 into that equation, you're going to get a true statement. Plug in, 1/5 into that equation, and you're going to get a true statement. Meaning any real number plugged in for A will make that a true statement, a true equation. Now, on the flip side of that, if you happen to do a problem and the variables cancel out on both sides, but you end up with a false statement at the end. A false statement like I've shown here, negative 2 equals 8. In that case, your answer is no solutions. Again, no solutions. Now, in that case, that means there is no number that you could plug into the original equation and it would be true. There are no numbers that exist that would make the original problem a true statement. That's why they say there's no solution. Alright, so a little bit of information there on the difference between all real numbers and no solutions. Alright, for our final example, number 5, a couple steps here. We're going to put our line down the middle. I'm going to look at the left side. I'm going to say first I need to distribute 16 minus 16k equals negative 10 minus 16k. Okay, now I want to get my variables together. Add 16k to both sides. Oh, I'm already seeing what's going to happen here. Negative 16k cancels with positive 16k. Negative 16k cancels with positive 16k. I have 16 equals negative 10. And we obviously know that is a false statement. And what did we just say about false statements? They have no solution. So for problem number 4, you're going to say your answer is no solution. Alright, so there were a few good examples there for you. You may start on the homework now. Good luck. Make sure you ask your teachers lots and lots of questions. Thank you.